Welcome to Study Loop.
What we'd want to do here is I'm gonna create a reference triangle, not to scale, not according to the um, coordinate plane, but we can use the points to find lengths. So for instance, AB would be equal to, using the distance formula, the square root of the difference between the x's, which is 4 between 10 and 6, and 1 between 7 and 6. And so that's the square root of 17. BC would be equal to the square root of the difference between the x's is 2 and the y's is 4. So 2 squared plus 4 squared, that's 4 plus 16, or the square root of 20 for BC. And AC, the difference between the x's is 2, the difference between the y's is 3. That's 4 plus 9, or the square root of 13. Now, we can find the angles by the law of cosines to start. So let's say we want to find angle A. We would say that side A squared is equal to the sum of the other two sides squared minus 2 times the square root of 17 times the square root of 13. I'm out of space here. We're still multiplying times the cosine of angle A. So that would be 20 equals 17 plus 13 minus 2 times the square root of 17 times 13 is 221. Just simplifying a bit here. 20, you could subtract 17 and subtract 13. You get negative 10 equals negative 2 times the square root of 221 cosine of angle A. Divide both sides by negative 2 and you get 5 equals the square root of 221 times the cosine of angle A. Divide both sides by the square root of 221 equals the cosine of angle A. And then that would mean the inverse cosine of 5 over the square root of 221 is equal to the measure of angle A. Now in a calculator in degree mode, we can find the inverse cosine of 5 over the square root of 221. And does it specify what to round to? Oh, in radians. So actually do not have this in degree mode, have it in radian mode. And we'll get about 1.23. I'm going to just go to 2 decimal places. 1.23 radians. From there, we can do the law of sines, which would say the sine, let's say we want to find angle B next. The sine of angle B over its opposite side, the square root of 13. Now that we have a pair, the A pair, we can say the sine of 1.23 radians over its opposite side, the square root of 20. Multiply both sides of the equation by the square root of 13. And then we can inverse sine both sides. We're ready to go back to the calculator. In radian mode, inverse sine of the square root of 13 times the sine of 1.23 radians over the square root of 20. And we get 0.86 radians to the nearest hundredth. And then you can do the law of sines again, or you could say there's pi radians in a triangle. And so we can just subtract from pi the 1.23 and 0.86 radians to get 1.05 for angle C to the nearest hundredth. Hope that's helpful.